My name is Andy Ford. I'm an SC manager at Apstra. So I've been at Apstra now for about 3.5 years. Been at Juniper for about a year. I thought it was longer, but about a year. And when I sort of came to Juniper, I was a consulting engineer. I'm now looking after a whole bunch of product SEs. So my focus is now product. So I'm going to spend the next sort of 30 minutes or so. I'm going to jump straight into a use case, a customer use case, and then I'm going to demo that use case, and then we're going to come back and I'm going to describe really the constructs of Apstra. So this demo actually is it's an EMEA. I'm a Brit, so this was an EMEA MSP, and they had a primary use case for a 5-stage Clo environment. They came to us actually and said we want Dell, we want Sonic, and we also are very interested in multi-vendor. They are growing massively as an organization. They're acquiring other companies, and their use case is also expanding sideways. They've just acquired a company that have a 5G use case, so they need to look at collapsed fabric, which we're going to be doing today. And they want to spin up these environments quickly. They want to template it, and they want to spin up a new environment, immediately. So we're going to go through this whole use case. I'm going to start looking at the reference design and the journey of Apstra, where we've come from and where we're sort of heading. And for the people who've never seen Apstra, I want to start looking at the smoke and mirror stuff, because well, through the demo, I'm going to do some stuff, and actually it does look like smoke and mirrors. Some of our customers have said that just can't be that easy. So I'm going to start looking at the Apstra constructs and describing exactly how we do this stuff. And once you understand, the bits and bytes, you can piece it all together and go, right, I've got it. There are no smoke and mirrors. So we're going to look at the secret sauce and stuff like that. Let's go straight to the demo environment. So this actually is this is the front end of Apstra. We're looking at all the blueprints. A blueprint represents a data center of some sort. At the very top here, we've got a view here of all of the blueprints. So each one of these blueprints is a data center, it has its own analytics. But at the very, very top, we can see here, the status of each one of those blueprints. And I can quickly, use these here to, if I scroll up here, I've got a blueprint for Barcelona, Copenhagen, Frankfurt. I've chosen all of them EMEA places, I apologize. London, Oslo, Paris, Stuttgart. Okay, so I've got all these different locations. And each one of these locations for this customer, it was this collapsed fabric, which I'm going to discuss in a second. But it was essentially a big standing VPN fabric. They needed to stretch layer 2 back to their core data center. And interestingly, their core data centers, as I called out, was Dell and Sonic, but actually the collapsed fabric and this whole 5G use case is all going to be Juniper. And we're hearing more and more. Actually, it's a really strange thing for me, because I've spoken internally at Juniper, and it was sort of clear in my head about a year ago that multi-vendor was a thing, but it wasn't really important to lots of companies. I think that's changing. That's changing a lot. And actually, most of our customers now are looking at multi-vendor for one reason or another, right? Supply chain or whatever. So if I jump into one of these blueprints. So here we have a blueprint. I've gone straight inside it. And I'm going to go to this stage tab here so I can get a view of what this looks like. So we have this environment. This is a data center, albeit a very small one, right? We've got 2 spines, we've got 2 racks. Here we have a multi-chassis lag pair of switches. And it is a Clo architecture, okay? This was built on Sonic. So I've got Sonic virtual machines in the back end here in my dev environment, and I want to take you through really what Apstra is, what it's doing. In this stage environment, DJ just now, he called out GraphDB, and what we're actually doing is we're using this declarative model. I'm trying not to use the IBM term, but we use this declarative model to build this entire data center in Graph. And GraphDB, as we know, is a great database for storing highly connected data sets. And that's exactly what a network is, right? So we're using this GraphDB, and from that GraphDB, we're using Ginger templates to derive the configuration. So this staged environment here, I can pre-stage an entire network. It could be a 3-stage flow environment, a 5-stage flow environment. It could be a collapsed fabric, but I can do it without a single switch inside. So I can pre-stage an entire, upcoming data center. So I've got this graph DB representation under this stage tab here. We use graph in lots of different ways to store the state of your, to store the running state of your data center, if you like, and all of the pre-stage changes. So I've got one for the active production data center that's running. I've got a graph database for my staged environment. So the difference between the two, I can see all of the uncommitted changes. So the uncommitted tab here will show me everything that I'm about to commit. Also, when we commit a change, we store that entire data center state in GraphDB in this thing called Time Voyager. So Time Voyager, I get to the end. So Time Voyager here, you can see I've set up this demo, but Time Voyager here, each one of these here is a graph data, a GraphDB representation of your data center. So any changes that you push to the data center are stored in here. So I can now roll back the entire DC to a previous point in time just by the manipulation of this graph. And you can see here, we started off, provisioning the underlay, overlay with VNs. In real life, these are going to be ticket numbers inside an organization. You couldn't put down the amount, you couldn't write in this field all of the changes that you were pushing to the data center at that time. So I'm going to go in and I'm going to make a change. So if I go into this stage environment here, I'm going to add a new rack. And this is where it looks a little bit like smoke and mirrors, right? So if I go in here, we can design a new rack at any point. I've got racks already designed. But if I choose this rack here, it's a multi-chassis lag pair of switches. I've got 3 devices here which are connected to these multi-chassis lag switches. And I'm going to add this rack. So let's just add it. So I'm pre-staging the addition of this rack, right? And what I'm doing here is I'm feeding this into Graph. So what I've done is I've made new connections in this GraphDB, and I'm going to use Ginger templates to actually derive the configuration, derive that validated configuration. And this is really the secret sauce of Apstra, really. So I've got these two switches. I've got some generic IP devices in this rack. One of the things I need to do here is I need to click on these switches. Let me go back, actually, sorry. I need to define in Apstra what these switches are. And I can do that by going to the device profile. Can you see that? And assign in here. I'll go through the modeling in a second of exactly how we do this, but assign in here exactly what these switches are. And here you can see that we're running Sonic virtual machines. So once I hit update, again, I'm pre-staging it. I can click on one of these switches. I can look at the render configuration. And here is the render configuration that Apstra has derived, the validated configuration that Apstra has derived. The entire model works this way. If we're building a 3-stage, 5-stage, a collapsed fabric, Sonic, Arista, Junos, Juniper, Junos, all works the same way. The modeling is exactly the same. And again, if I look at that stage tab, I pre-stage this new rack here. If I go to the active environment, that active environment, actually the rack doesn't exist. I've not pushed that configuration. And if I go to my uncommitted tab, I can now see the difference between those two environments, everything that I pre-staged and everything that's actually running in production. So I've done something really, really complex. And we can be deriving, a configuration for a switch, which could be 1,000 lines long, and it can be done in literally a second, as quick as you can push that button. That validated configuration has been derived.
I think too, on the reliability piece, what you see here is to gain confidence in what you're going to do. Imagine that you had another vendor. I mean, it's pretty common today. We had a conversation with a customer, just couldn't get supply chain. And this could have easily been a different vendor that your operations team or you're not necessarily comfortable with. And you can choose a different vendor, put it in, look what the, understand what the configuration looks like, get a cable map, et cetera, without ever even touching production.
Yeah. Yeah, and you know, a lot of our customers see the value in this in lots of different ways. Supply chain is one of them, but the value that our customers see is they can use this tool. The architects can architect, and it's hardly DC, but they can deliver this same tool to ops to deliver all those data changes in exactly the same way, the same accuracy that the architect would have done from day zero. Yeah, so the use cases are very strong, actually very, very different.
Can I ask a quick question here?
Sure.
Like the adding of the switches, the pre-staging, you added those switches directly. Can that be pulled from a source of truth or an inventory database?
Yeah,
or is this meant to be the source of truth for that?
Yeah, I mean, everyone's got a source of truth now, right? But I mean, there's a modeling in Apstra where we describe what this switch is, how it's connected, and ultimately what the real physical switch is that we're going to deploy. I'll go through that in a second in the slides. And so we model it, because at some point you've got to derive the configuration for that real physical switch, right? And they could be very different. You may be building a configuration. You've got a 25 gig, requirement, but you've got a 32 port QSFP28 switch. I mean, you've got to describe in Apstra how we're going to consume those ports. So a lot of that modeling is done. That single source of truth really is GraphDB for us, but we integrate with other tools. Yeah, easily integrate with other tools to pull in, other information that we need. So yeah, it sort of depends the value of that integration, where that single source of truth should be, or what data you need to pull from it. But.
So I guess a good question is, we don't reduce complexity, we shift it typically. And this question about the maintaining this multi-vendor environment and mapping the logical representation of a blueprint to physical switches, how much overhead is that on a team to now have to say, okay, this Cisco device, this Juniper device, or this Dell device running Sonic, is this category, it's a leaf one, leaf, or a spine type device. Like, how complex is that?
I think there is complexity in it, because, as we all know, standards aren't always that, we have a standard, but it's not implemented the same way by the different vendors. So often they will not meet in the middle. So you need to have some knowledge of what you're trying to build and how that multi-vendor stuff plays out. Actually, I think we only have one customer globally that's deployed two vendors, unless DJ's going to tell me differently. We've got one customer in EMEA who deployed two vendors in a baseline VPN fabric, and that was Cisco and Arista. And if you keep the planes separate, the spines from the sort of EVPN plane, then you're fine. That'll work, right? Because you're just, if you can't get the BGP stuff right, then you've got another problem. But largely the multi-vendor stuff is fabric by fabric.
Yeah, I'm not even thinking about multi-vendor. I'm thinking about like practical customer stories where,
right,
I can't get X because of supply chain. Everyone's having supply chain issues, and I'm deploying 5 different data centers.
Yeah.
And you know what? I'm going to have one vendor in one data center, another vendor in another. So not even missing leaf spine. Yeah. But I now have, like, in each data center, I might have 3 or 4 different categories of switch. One for my virtualization stack, another one for my bare metal stack, another one for the spine. And that becomes, potentially, 15, 16 different SKUs. Yeah. And then I have to represent those SKUs in Apstra and maintain that graph database. So connection back to that physical world.
Yeah, and this was something I was going to get into my presentation, mostly around hitting on it from an automation standpoint. But you're right, the overhead of maintaining that is high. Mm-hmm. I see it with the customers I talk to. I see it with the network engineers that I talk to. They're dabbling into automation. Us as traditional network engineers, we haven't noticed it in the past because we handle it mentally. And it's all in our head, and we do it manually. We process switch from version to version of NOS. We process switch from vendors, and we maintain our Excel spreadsheets of templates. Or nowadays with automation, you're managing your Jinja templates. The complexity of that is huge. nailing it down and stabilizing it like DJ was getting into is complex. It was hard for us to do. Took us a while. When you go to a tool like this, you're not doing that anymore. You're focused and you're relying on our system to handle the complexity across vendors. You might not be using multiple vendors, you might just be using one, but we're handling that complexity across versions. We're also, if you have certain configurations or certain things you're trying to do, we're going to normalize that for you. So if you're deploying it to data center one, who's in a certain scenario, maybe they're running MLAGs or ESI to do redundancy, that gets deployed in this manner. But if you have a singleton rack that only has one uplink for whatever reason, or it's a different format, we normalize all that. We simplify it. So you don't have to worry about that. You have to worry about what does the architecture want? What are my requirements? And then plug those into the system and let us take care of the rest. So to recap all of that, we shift the complexity, like you said, but we take that workload off you. Your team does not have to worry about that now. You can now worry about more important integrations or more important workflows that stabilize your data center now.
So to build on that, like you've got some loopback IPs, are you guys creating IP addresses, ASNs, any of the BGP settings? And if so, how are you making sure that you're not overlapping? Is that all centrally, is the intent that you guys have the full vision of everything and you know what's in use so you can kind of randomly pick something, or how does that work?
Yes. So you hit it pretty close right there. So we have two options you can go with. So we are very opinionated on what you're deploying. We have the understanding of what the fabric needs to do. We deploy what we feel is the best practices there. Now, obviously, ASN pools, IP pools, resource pools, that type of thing you can plug in. Now, there's two ways you can go about it. You can do the traditional way where you statically plug those in as you go through, and then you go through another process to update your IPAM solution or netbox or whatever you're doing. Or we have a concept of resource pools. And you get into your resource pools and you can statically set up the pools to pull from certain subnets. Okay, and subnets or ASN numbers, whatever. And the notion is that you're going to whatever your Excel spreadsheet or your IPAM is that manages all your IPs, and you're saying, hey, this Apstra fabric needs these types of pools. Allocate those from here, move them into Apstra and assign them. And then Apstra, when you're building resources, new VLANs, new racks, new VRFs, whatever you're doing, and that's kind of what I'll show, you're pulling from those pools. What's the next available out of that pool? And so from a higher level organization standpoint, we just know that Apstra has these set of pools. But you as an engineer don't necessarily have to worry about which ones are getting used where and how many need to go here, there, and the other. And you don't have to update your templates. You don't have to update your workflows to inject that stuff unless you want to. So we own that all the way through.
And you guys, I presume then you can make an API call into, presuming that the IPAM solution is, addressable that way. You can make an API call to just grab the next subnet or whatever it might be. Grab this, reserve it, and then ingest it. And then, you do what you're doing with it, but it's not necessarily a manual process for an engineer. That could all be automated.
Both, yes. Yeah, very easily.
Wait.
Yeah, cool. Yeah, to extend with that as well, you may want to allow overlapping address spaces, right, for your different routing zones, and that's all taken care of in that Apstra solution. So I've got this new rack. Actually, there's a workflow that we go through with Apstra. If you start at A and end at Z, and you completed that workflow, Apstra's happy. You can commit that configuration. If there's part of that workflow you've missed out, we're going to stop you from committing a partial configuration. So everything's validated. Everything you push is going to be validated. There is actually one part of it which isn't validated, which lives outside of this model. And, depending on the sort of vertical you're working with, we're working with MSPs and banks and telcos, and actually they've all got they've largely got the same or similar use case, but they've got differences. So a bank's going to want B2B authentication, and stuff like this, right? And there are aspects to that entire design which need to be delivered in a slightly different way, and we'd use a config look for that. But that's really getting you to that last mile, right? So we've got this new rack. So we're ready to push the configuration. I actually don't have any virtual switches to push it today. So I can actually, I can decide in my uncommitted tab here whether I'm going to actually push it. So the commit in the top right, or whether I'm just going to revert that back to my previous state. So I'm just going to revert this back. So my staged environment here, that rack will disappear. So I can pre-stage this stuff up. I can look at the configuration, I can tear it down. I can pre-stage something new. I can look at configuration, tear it down. So I can go through lots of iterations of what my next, data center configuration is going to look like. And manage it all in this tool. So analytics is an interesting thing because if we store your entire data center in graph and we know the vendor that we've assigned to these switches, we can derive lots of things from this graph, right? We can derive things like EVPN root type 3 tables, type 5. We can start to look at lots of different complex things from this graph, using it as a single source of truth. And I've got a small demo here today. If I go to the dashboard, so here actually, this is the high-level dashboard out of the box. This whole validation piece, if we literally push this configuration day 0, there's no need to test whether the configuration has worked. We know it's going to work. Okay. If there are cabling issues, some of our customers initially didn't take the cable map from Apstra. They just went into the data center and cabled everything up, and then we came along, pushed configuration, and we were saying, well, we were expecting a BGP peering on this link. We're expecting this to happen on this link, and it was a mess. We had errors everywhere. But we instantiate LDP, so we get all the LDP neighbor information from the switches, and you pull that back into Apstra, and then correct the graph to match the physical network.
Question for you. So after you've got your data center all stored in there, you're mapped out, and let's say you're going to go through a hardware change out. You're satisfied with what you have today, but due to shipping delays, we're going to get this platform out, and we're going to do the hardware switch out down the line. How difficult is it to rip out your old data center, take what you've already designed, and apply that on a new hardware platform?
That's just done through the modeling. I'll show you in a second how we do that. I've got a nice sort of diagram which sort of describes exactly where we go from this logical representation of a switch to the actual physical. And you just need to create a new mapping. So let's say I'll give you a good example actually. So let's say we're going to swap out a leaf switch, which is somebody ports a 25, somebody ports a 100 gig. I'm going to swap it out for a 32 port QSFP 28 switch, but you still need that 25 gig requirement. So we can just create a new mapping. We have the logical device, which represents your end state, map it through to the new switch that you need, and you can just swap one for the other, and that Apstra will derive the configuration for that switch. Mm-hmm. So in the same way, for swapping out the whole DC, it can be done exactly the same way. I'll do that. I'll show you that modeling in a minute, and it'll become a little bit clearer of how we do it.
Okay. If they're the same, when you see it, if they're the same like model, let's say it's a 32 by 40 from one vendor, and you want to switch it to a 32 by 40 for another vendor, it's like 2 clicks.
Yeah.
Okay.
So what I've done actually is everything's virtual here. And my switches are virtual. Everything in the backend is virtual. So what I've done is I've actually gone in and modified the graph DB representation of where everything is connected, and it's produced a cabling error. Right. And this cabling error here, we can get an overview in text form. I'm a sort of a pictures guy really. So if I actually go to this leaf here, we can give you a nice representation of what's connected and what's wrong, what's present, what's absent, what's down, what's up. And all this is just coming from LDP, right? But also this particular cable issue has thrown up another anomaly. Actually, this is a leaf spine connection. So now Apstra sort of saying, I was expecting a BGP peering on that link, and now I don't see one. So it's constantly validating the production network to make sure it's running as expected.
So we also
does it feed back those warnings of the cabling errors in some format so that somebody can then go correct where the static cable map is stored, whether it's an Excel or a two-light neck box or something else?
Yeah, absolutely, yeah. So
okay,
it
doesn't hide it.
Cabling map, JSON format and Excel format. We can use the API to export out to anything that you need.
Okay. The other options here is all of our telemetry data can be streamed off with Google Protocol Buff. And so any of these types of anomalies, anything that gets raised here, they can be streamed off and kicked off to various monitoring services or wherever you want that flow data to go to raise those types of issues. But like you said, yeah, you can pull the cable map out, hand that off to your data center team, and have them off to the races.
The dashboard here is throwing up the anomaly. It's telling you exactly where the problem is. It's a spine leaf connection. It's giving you the ASN's IP addresses for source and destination, and giving you the expected state. But it's doing it here actually for EVPN address family and IPv4 for both ends. So I've got a problem from here to here and here to here. So the other point here as well, and really the main part of my presentation, which is taking a bit of time to get to, which is this collapsed fabric. This particular customer, this MSP, as I said, they've acquired another company. They got this 5G use case, and the CLO architecture is just too big, right? There's too many switches, and they wanted to look at something a lot smaller. And this is where this collapsed fabric comes in. And here they've got one. I'm not sure if I should use a pane of glass because lots of customers say I've got many single panes of glass, but they've got one touch point here where they've got visibility of all of those locations. They had a very specific requirement. They needed VXLAN VPN in these locations, but just 2 switches or 1 switch in some cases. But they also wanted to extend layer 2 back, actually with OTT, right? And which can all be done in Apstra. But they wanted one touch point, one place to give visibility of all this entire environment, all throughout Europe. So as I said, each one of these blueprints represents a data center. And actually all of these here are just pre-staged. I don't have any sort of VMs to push config in the back end, but I've just pre-staged it. The colors on there are really awful. But we've got a couple of leaf switches here. There's a mesh link between the 2 of them. Find it here. And in this particular environment, we've got a couple of access switches, and I got a couple of devices, one connected to the access switch and one directly to the leafs.
So what's interesting here is if you see there's 2 switches, and he's going to go through, like the history and the evolution where we've expanded the use cases to this edge use case. But what you're seeing is ESI is this, a standard-based protocol all the way out to the edge using EVPN instead of using proprietary protocol like MCLAG. So we're using that same technique, even though there's only 2 switches. And that is, really important for the customers is that they don't want to be locked in at any point in time. Like when and where that you can use a standards-based protocol that is interoperable. Everything we do and all the implementation that we do is always, first conscious is how to make this vendor interoperable. How can we make this vendor agnostic, and how can we, deploy these in a standard-based way? So everything we do is in standards-based way.
Right. Okay, good. Yeah, so where we started out, it was a 3-stage CLO architecture based on EBGP, VXLAN, EVPN. The one sort of core difference between Apstra and Juniper actually was Juniper's model was CRV, and we placed that with an ERV model, so distributed routing. And anyway, so this is where we started. But soon our customers needed scale, right? So we had to meet them on that scale journey. So we designed a 5-stage CLO architecture. This uses exactly the same modeling as the 3-stage, exactly the same. It's just an extension to that. And from that, we had this collapsed fabric use case, which I called out, where customers have a smaller environment and they don't need a 3-stage CLO architecture, but they want VXLAN VPN, they want DCI, et cetera, et cetera. And this was really key for this managed service provider that I'm directly engaged with in EMEA. And you can see here, we've got 2 switches, we've got this mesh link, and we can connect, resources directly, nodes directly up into those leaf switches. We can deploy 1 switch, we can deploy 2. So there's flexibility there, right? We can extend that now. So if they have like a 1 gig use case, we've even had customers have a 100 meg use case, which is crazy, but it is what it is. But they can drop in some access switches, and these can be managed or unmanaged. So if a customer has, a switch that we don't support, they can drop that straight in and just connect layer 2 down to it and manage it themselves, right? But there's a lot of flexibility here to do what you need.
Yeah, the other use case for this is to Andy's point, is not only are they lower speed devices, but also if there's a lot of license, in some cases, there's licensing cost for like EVPN, if you're running it all the way down to the access. So this model here is particularly user when you're deploying it like really dense scale out at the edge, 5G use cases. And you can also, those the two boxes at the bottom, the L2 access, they're not running EVPN, so you're not paying for those licenses. So you're saving on license costs there. So you can support if you look at this, it looks like a similar topology, but the configuration is rendered, the license it takes to do this is a bit different. So it's for customers who are cost conscious and deploying out at the edge, like at scale and distribution, this was a reason for them to go to this model.
Yeah. So we've touched on this. I want to quickly sort of go through it. This is usually the slide we start with, interestingly, but it's really good to show you a demonstration and guide you through the tool. But this is essentially what we did. We started with this declarative model. We started with this end state in our minds, and we built it within Apstra in this staged environment. And all we're doing is feeding this data into GraphDB. And this really is the single source of truth for Apstra. And we use then all of the contents of that graph with Ginger to build the validated configuration that we then push out to the switches. Again, as we store everything in this GraphDB, we can derive lots of really meaningful information out of it. Okay, so as soon as we say, right, this is a Junos network or a Sonic network or something else, we know exactly what the routing table should look like. The whole validation piece and the whole continual validation piece is actually quite an important part, right, of operations. So this is what I was talking about. This is really the how we do it piece. So we start off with this logical device, and it's quite simple. It just represents a switch in your fabric. It could be an axis, it could be a leaf, it could be a spine or a super spine. We're saying that this is the number of ports we need. These are the speeds we need. This is where these ports are going to connect. We have this other thing called a device profile, and I actually call this like a single source of truth for a given physical switch. So we have a profile for all of the vendors that we support. We support Juniper with Junos. I'll go through it actually. So the mapping bit that we were talking about, I sort of called it out already. So if we have, so let's say we started with a switch which had 48 ports of 10 and 25 gig and 8 ports of 100 gig, but we wanted to swap that. The original requirements stayed the same, but we wanted to swap that switch out for another model. You can still get that port configuration from a 32 port QSP28 switch. The interface map describes to Apstra how those ports are going to be consumed, which ones we're going to channelize. So you can just remap it, okay? And the model, the abstraction here, the model actually is exactly the same for each one of the vendors that we support. So to DJ's point, where we can just go along and swap out a Juniper switch and plug in an Arista one, that's 2 clicks and it's done. Maybe 3 clicks. So, yeah, so, again, we've sort of spoken about this. We have this one system, it's multi-vendor, everything is validated. We have integrations with vSphere, with NSXT. We can drive the entire platform with Python, with Ansible, through the API. The NSXT stuff is quite interesting, and vSphere is quite interesting because more and more customers now we're seeing is deploying Geneve. Lots of customers are deploying NSXT for microsegmentation, not for the overlay. And in the integration that we have with that technology, networking is networking, right? So if you want to EVPN peer with a T0 router for NSXT, we can do it. That's just networking. But we have a whole operational continuity model as well, where we're checking to make sure that the configuration from that technology plugging into your leaf switches is correct. MTUs, VLAN ID mismatches, and stuff like that. But yeah.
How close of a relationship do you need to have with the multi-vendor community to be successful? Like, as far as supporting new features and things like that, are you plugged into their engineering teams to be quick to market, or is it, you got to read their data sheets when they're released and things like that?
So if you think about what Apstra is doing, we have a reference design and we run multiple hundreds of thousands of P-tests continually to validate that reference design. And the additional features that a customer may need would probably sit in that configured area, right? So they still need to be validated independently of the reference design. So if we're working with a customer, like, let's call out the bank that I'm working with specifically. Actually, they're called out, as we got the logo here. It's a bank in Germany. They wanted this. They called it MD5 initially for BGP authentication. They actually started off looking at a number of other NOS vendors first of all, and they decided themselves that actually the better together store is more important for them. So they've chosen Juniper as a platform. So it's Apstra and Juniper together for this one bank. But they needed BGP authentication, and it's not in the reference design. So we needed to go away with them and look at how we model that through a configured. And actually, we're using TCP AO. So we're now implementing TCP AO at that level to implement that feature. As I said, that's done separately, right? That's not modeled within the solution.
Yeah, I would say it's being a Juniper, it's significantly easier because we use the tech. But there is a fair amount, to be honest, of reading the data sheets, looking at their design guides, seeing where the rubber meets the road. Oftentimes you'll see contradicting information of how to implement one technology from the same vendor. And so that's the work that we have to do. So we'll go through, we also participate in the ETAC, which is this multi-vendor consortium where everyone gets together and does like this interop testing. So we do participate in that. And that gives us a good baseline of say, what does this feature look like? Where are they going? As a good example, as we look at things like VXLAN stitching is what Juniper calls it. Arista calls it like integrated gateways. Cisco calls it multi-site. Those sorts of technologies, we'll have to do the evaluation, do the work. But we don't have any access to like in Juniper, we'll get early access and we can develop faster. If there's a feature from another vendor we want, we just have to go and do the work with engineering.
Right. Okay. So if I understand correctly, you're modeling some pretty common designs, and if anything special is needed after that, then you got to apply the engineering to that and do the homework to.
Exactly, and that's a big value prop for the customers. Is every release, and I think in the past session or recording we spoke about this, but we run about 17 million tests a day across hundreds of different topologies. And we use that same infrastructure when we're building out new additions to the reference design. And so what that means for the customer is that when you get it and you get this feature that that when you upgrade it, that the behavior is going to be the same. The output from all of the vendors are going to be the same. The validation and it exists. So you don't have to essentially, like when I was in operations, we would say, well, we want to get this feature, and we would sit there and take like a month to qualify this feature and turn all the knobs and see if it interops and change all the thing. All of that is, handled. So that's one of the, benefits and value that you get from Apstra.
So what happens when this breaks? Back it up. There's no other solution like Apstra on the market, just not.
Thank you.
So, I mean, for good and bad. And I think the part of the challenge is what happens when I'm managing a bunch of Cisco 9Ks at the edge with this, and something breaks, and someone and the Cisco tech gets on the engineer on the call and says, "Okay, let's log into the switch and make this change."
So that's the nice thing about our product is we don't configure it any different than you would, and we don't lock you out of access into the switch. So unlike other solutions or other products out there, you log in, you do a show run, or you look at your configuration. It looks the exact same as you would configure it. You could even log into the switch and start making configuration changes yourself. Apstra is going to alert you on that those you're starting to deviate, but you can't. you don't lock that out. So your engineers that are still reliant on the API, or not the API, but the CLI to troubleshoot, or the CLI to pull information out of the device, they can still use those tools and those methods that they've used forever, especially at 3 a.m. in the morning when they're still waking up to troubleshoot an issue. They can still do that. But we now give the higher level abstraction with Apstra to look at it holistically across the board. Now, getting into the case like the Apstra controller just completely blows up or disconnects from your edge or whatever, we're not in the data plane there. We're not fully managing that switch and it doesn't go down. It still operates just fine as long as that running config or the configuration is still in place. So you don't lose that. Now you lose the telemetry data that's getting pushed back to Apstra. You're losing that information while Apstra's down, obviously. But yeah, that's.
I think operationally on your part, if you were asking more about like from a user perspective, what is my experience when I'm running multi-vendor with Apstra and there's a case? So we always take first call, and we will troubleshoot all the way down to the vendor. A good analogy here is that when you buy a PC, there's not a lot of PCs around. You got to think that. There we go. And so like, that's running Windows, or it could be running Ubuntu, but he's likely going to call like IBM as his first call. So it's a very similar model. Like you call Juniper, call Apstra, you work with our tech. We have, support systems and structures that are deeply familiar with all the operating systems and nuances. We'll troubleshoot it all the way down, to ASIC levels. We've been down to ASIC levels, and we do a handoff. We do a handoff to the vendors, provide all the JTAC tickets to them for them to, provide the bug fixes and et cetera. So we are that single, source, that single throat to choke, I guess.
So we haven't used the term, and it's maybe not appropriate for this part of the presentation, but we're talking basically infrastructure as code, managing my network as infrastructure as code and operationally. So you brought up, kind of this changing, support. If the NOC needs to make a change to a switch and they're not doing it through a configlet, then bad things happen from my pipeline perspective. So I'd love to get into that conversation of how customers are dealing with that transition of model from hands-on plea changes to now Apstra being it's funny, you guys use the single source of truth there, the single source of truth until, well, the single source of truth I think is right because you're collecting telemetry data from the switches and changes, but it's not this. It's hard to make it force it to be, from a policy perspective, the single source of configuration. So we don't have to. If there's a whole session on that, then we can.
Yeah.
My presentation is going to dump into that, and let's try to re-engage that there.
Mm-hmm.
But yeah, there's some discussion points around that.
Yeah, so we're going to hand off in a minute to Ryan, who's going to go through that whole piece. And this particular customer, again, I'm working with in EMEA, they have a requirement to refresh 4 data centers. Multivendor was a really strong call for them, really, really strong. They had tried and tested our competitors' solutions, which I'm not going to call out. And their particular use case actually is to embed Apstra deep in their pipeline. And they're not going to use the UI at all. So having that strong API was absolutely key. And they literally took our product and, for want of a better term, just tore it to pieces. And they went from a 1.5 year, testing cycle with this other vendor, and with Apstra, they've come to a conclusion literally weeks later that they're really on the right path now. And to give you some sort of idea of scale, the first data center, they're standing up 2 halls with 128 racks of 2 switches in each rack, 2 halls. This is going to be based on Cisco with an XOS. The next data center they're looking at is Dell Sonic, and they've got 2 more to do after that, and they haven't decided which vendors they're going to choose for those other data centers. So that whole vendor agnostic piece is super important for them. To drive each data center in exactly the same way through that API is priceless, absolutely priceless. We've gone through where we started. We've gone through this collapse fabric stuff very briefly. we've got some really cool stuff coming, which legally I can't talk about at all. But stay tuned because there's some really interesting stuff coming from Apstra.
Just a quick question. If a customer had something like Cisco ACI, were you able to integrate into that so that you could actually just have your product, single source of truth, to actually run with ACI in the background?
We get that question an awful lot, an awful lot. And unfortunately, the answer is no.
Okay.
But we get that question a lot because there is a lot of hidden complexity there, which the customer really wants to get it, out of the way.
So on that topic of ACI, so if you're an ACI customer and you say, okay, I've had my fill, I'm ready to switch.
Yeah.
Do you have an easy way for them to port over what they've already designed? Or are they starting from the ground up?
There's, so in that case, there's a few different ways we do it, but we have it was just launched this quarter too. I'm really glad you asked this question. So we have a migration services, a few different types of migration services. One is like where you want to move to something new. You have some data center legacy and you want to move it and migrate it over. And another one is where you have an existing infrastructure and you want to, similar to your case. So there's some software tools that the professional services is built that essentially does an audit and extracts out the high level things that is important to how that data center behaves. So it's like, okay, you have a VLAN, they touch this number of ports and et cetera. So they extract all that information out and then feed it into Apstra, which dynamically builds that topology for you.
But then saying the word VLAN when talking about ACI, that's not how ACI
right,
works
with the bridge
because of the complex. Yeah, it's the BDs and the EPGs and whatnot. So you're working to be able to extract that and convert it over to
and translate it down. Yeah, there's because it is so different. There's some manual work involved with that to make sure the translations are accurate. So that is to say that we have both software tools and the professional services that, and we've done at least 2 in the past, I would say quarter or 2, that is exactly that.
Well, one of the really cool things actually is because this is a multi-vendor product, is we had one customer, we just recycled the entire DC. So we repatched our ACI environment, freed up some switches, built a whole new topology next door, connected it all layer 2, and then just rebooted those 9Ks under Apstra. Put NXS on top, design the configuration, everything's validated. And then just ultimately at some point you're moving the gateway across, right? So you move all the services and move the gateway, but we were literally swapping out switches, building with NXOS, plugging them into Apstra, moving the services across.
So you could, sorry, go ahead.
No, I was going to ask Ryan, part of your presentation, that deployment model, is Apstra meant to be a lift and shift or lift and migrate? Is it a upgrade in place? When I think about adopting Apstra as a operating model for my data center, how should I think about that transition? Is it replacing, my current design and you're just managing my current design, or net new pods?
So there's various approaches to that. My mindset with that is when you deploy infrastructure manually, it's outdated and off of architecture 5 minutes later. And so taking what you currently have in place and moving it into our model and allowing that validation and allowing the deep level of intent into knowing that is almost impossible to do. We have to make a ton of assumptions, and those assumptions are what burn us. So the notion is you want to drop what you have and implement what we have. Now that means you got to shift from those configurations to our configurations. Migration strategies can go any one of those ways. You can take an existing infrastructure, existing pod, pull it out of production, drop the BGP period, whatever type of bleed down you want to do, tear down the configurations, implement Apstra, stand it back up, and validate that everything comes back up like it should. That's a way you could approach it, but you could also approach just a full lift and shift if you want to.
Yeah,
you can use any of your normal models there.
We've had customers do all of them. Interestingly, they built fabrics alongside migrated services, or literally gone big bang, and they've just rebooted the fabric under Apstra. Because you can model the whole thing, right? I can build their entire environment they have now in Apstra without any physical switches. You just need to plug in and reboot, and we're up. So yeah, it's sort of depends where you see the risk and what infrastructure you have and what cycle of change you want to go through. But Every customer sees it differently. Sorry.
Yeah, so in a situation like that, let's say we have a data center, we want to move into an Apstra platform. And let's say that that data center uses features, services that are outside the scope of Apstra. You had mentioned Jinja and Configlets a couple of times, but didn't really explain their kind of purpose in the regard of how a customer, and to your question, Keith, like, are there any restrictions or limitations when you're trying to do a migration of that sort? So for example, let's say I'm using multicast or PTP or just something that's really important to me, but isn't probably important to, you know, the general template blueprint structure. How do you guys address those nuances or customizations for?
Yeah, those customizations, they can be really simple or really complex, like multicast and the overlay with OISM. That lives outside of our reference design, but we use configurates and Jinja templates to derive the configuration for that in a very dynamic way. So they can be super simple. I want a message of the day which looks like this, or my NTP, you know, details look like this, or they could be super complex. And that really is the power of that sort of configurate add-on, where the Jinja is embedded within it. So yeah, it can, and you know, there is some complexity there without a doubt. And you look at all the verticals we work in, they've all got that little bit on the end which they want, like the TCP/AO for the banks, and you know, they've all got those little pieces they need, and that makes the migration strategy a little bit more complex, but it can be modeled.
Well, so let's talk about modeled versus configurates, right? Like when I hear the word modeled, and the real secret sauce that I see out of Apstra is when the model changes, then the validations change as well. So if I add a new rack, I have to validate that that rack is there. I run all my show commands effectively. But when you have a bank, and I'll use that example because I don't know it, and you have this bank and it's probably using some weird protocol that I never heard of, and you say the model supports it, does the adaptation you make for that customer, does it invent new validations to validate that it's operationally meeting the expectation of the design, or is it limited to the configuration aspect exclusively?
I think you're asking, so in the spirit of transparency, there's some things that you that would conflict with the Apstra data model. So as an example, we run BGP overlay and BGP underlay. So a customer can, you know, an example where you couldn't use a configurate is, you know, I want to use IBGP for the underlay. So that's, you know, like a prime example there where we're focusing on outcomes. Like you want to build a data center, you want it reliable, you know, like BGP is to that. There's others, like as you said, that maybe multicast is very important for many of the people in this room. So we could configure that, and there's even ways for us to get telemetry for it. In a configurates, we also support Jinja and Python inside of configurates, and we'll talk more about that in the future. So it can dynamically render configurations on runtime. So when you add things, but there are limits to how much context that we can derive out of those configurations that are driven by configurates because they're not properly modeled in the data model. So something like, if I would say multicast, we'd be able to say when a VN is implemented or when you provision a VN, we're going to render the multicast and we're going to make sure that there's no deviations to that. And we can do it dynamically, but we may not be able to give, like, you won't be able to ask Apstra a rich context question, like, tell me all the RPs as part of this multicast tree.
Right. Yeah, that's, do you see Apstra evolving the platform in that direction?
100%.
Yeah. Okay.
So when you start looking, maybe as you guys go through this, you'll start getting into some of the configurate stuff. But is that something where, like, if you get Ansible playbooks or something like that for the edge, kind of the non-modeled stuff, could you use Ansible or could you just call an Ansible playbook, or how? Trying to kind of wrap my head around those edge configs and how you want to put those in.
You apply those inside of Apstra.
Okay.
So you go into, let me just get here ad hoc. So here's what I'm going to use my demo. Here's our blueprint fully deployed. Come over here into our staged infrastructure. So this is where we're going to stage all these changes and walk through to validate that everything's good. So you apply your configurates here. And basically when you build configurates, you would build them under resources, design, configurates, and property sets. Property sets are basically simple key value pairs that you want to pass in as variables. They can be complex key value pairs, however you want those to go, but they can be passed in. But here's configlets we have here that are pre-configured. So US message of the day, simple one, just simple message of the day. We're going to dump in there from legal. NTP server, so we can do that per data center, per region, however we want to set those up, and they could be applied to the devices or the racks or the blueprints that you care about. And then of course, NTP and just various other ones. Mac aging one is specifically, say you have some weirdity with a vendor or a specific deployment where you need to apply certain config to help with some things. That's how you can apply it. But coming in here, let's do NTP server. You can see what we have here is the various vendors. So when you do it, you pass in your vendor, which is, this is an XOS. We got EOS, Junos, and Sonic. These are the configs, the raw config that you're pushing in. You can see the variables in Jinja format that you pass those in. And for each vendor, you pass in basically what it's going to take to apply it and what it's going to take to remove it. And then from there, you go back to where I had showed and you applied it to the blueprints. And so once it applies, you don't have to worry about Ansible doing all your push and pull model. You don't have to worry about it doing your variables. We handle all that for you. When we take this, it applies the config, it validates that the config was applied, and then it backs off and lets you know that it was good in the blueprint.
Wait, say that one more time. Like it does like a test on a device to see that that was a valid configuration for the device?
That it was applied to the device. We don't validate that what you're passing in is giving you the intent that you want.
Right.
You have to do that yourself.
Right.
We validate for you that what we're taking and applying to the device was applied to the device.
So let's say that I wrote a configlet for an NXOS device, and I want to test that configlet. I think that's what you're saying. Is like, I want to test that configlet. I test it actually on a live device. I pick a device, kind of like, you know, you're the sucker. I'm going to hit you up.
Canary.
And it basically does a temporary change, make sure that the config would have worked, and then backs it out. Okay.
So if I'm in ACI and I'm done with ACI, I can pull the ACI firmware off my Nexus 9Ks, convert those to NXOS, and essentially just reboot my data center on Apstra. I don't have to recable. It's a software swap out.
Just ad hoc thinking through that. Yeah, you tear it down, run back through a ZTP process where you pick up our agent. That's how we manage the device. We drop an agent on there. You pick up the agent, or we can push that through a workflow through Apstra to manage the agent. Agent gets on there, connects up to Apstra, and then from Apstra, you build and deploy from there.
Okay, cool.
Yeah.
Some of those sort of complex custom scenarios, are you seeing the actual end customer performing that configuration, or do they just engage professional services with you guys?
For which type of configuration?
You mentioned multicast, for example, sort of on the...
In my opinion, I think that's where you really want to go with professional services to engage with us to build that out. It's definitely doable depending on what type of shop you are.
Okay.